In the Northern Hemisphere, winter arrives with lethal efficiency. As temperatures plummet, freezing rain and snow lock the soil in ice, stripping away nearly every visible trace of life. These stiff, bare branches mask a highly evolved, heavily coordinated defensive sleep. Deep within the timber, the ecosystem is entering a state of calculated dormancy. Broad-leafed trees cannot survive sub-zero exposure above the surface. To protect themselves, they abandon their own branches. Their sap and life-giving energy are driven deep underground, stored safely in their insulated root systems, where the fatal frost cannot reach them. For the animals left behind on the surface, this defensive strategy creates a desperate situation. The European bison, wrapped in thick fur, must wander this frozen terrain in herds of up to 50, forced to survive by scavenging meager calories from tree bark, moss, and fallen branches. Squirrels avoid this daily exposure almost entirely. Instead of battling the elements for bark, they retreat into deep hibernation, emerging only on sunny days for a few hours to tap into precise caches of seeds and acacia fruits they buried before the ground hardened. Surviving this environment requires mastering absolute patience. Every organism here is simply holding its breath, enduring months of scarcity for a guaranteed future reward. That reward is spring, and it triggers a violent biological explosion. As temperatures and moisture rise, the trees race to deploy wide, broad leaves. They have a brutally short window to capture sunlight, bloom, produce fruit, and store enough energy for the next winter freeze. This sudden boom of food forces a massive influx of life. Millions of birds, including colorful European rollers and bee-eaters, travel thousands of kilometers to breed here and exploit the brief, intense abundance of insects. With the cold returning in just a few months, breeding must happen fast. This tight schedule forces complex courtship tests. Male rollers must prove they are capable providers by offering freshly caught insects to females before mating occurs. Even the decaying debris of the forest is drafted into this rapid harvest. Dead trees become dense habitats for xylophagus, wood-eating beetles. The beetle larvae are then heavily hunted by black woodpeckers to feed their own demanding chicks. But the biological clock is strict. Before the cold fully sets in, trees prepare by actively cutting off nutrients to their own leaves. The green chlorophyll starves and fades away, exposing the deep red and brown pigments hiding underneath. Millions of these detached leaves bury the forest floor. As they decay, specialized insects, fungi, and microbes break them down, turning the dead matter into a rich, fertile layer that sustains the roots. The temperate forest operates as a rigid boom and bust economy. Every plant and animal is locked into a schedule, racing to gather wealth before the changing seasons force them to shut down once again. Now, imagine an ecosystem without that biological clock. How does life evolve when winter never comes and the race to gather resources never stops? This climatic dashboard shows the strict baseline required to build a true rainforest. It must register a minimum of 100 neurometers of rain every single month. That constant water creates 80% humidity, locked alongside a static temperature between 27 and 30 degrees Celsius. These exact conditions define the neotropical rainforests of the Americas. Fed by immense river basins carrying heavy volumes of water, the landscape explodes into a massive layered canopy where direct sunlight rarely reaches the ground. Navigating this endless, chaotic abundance requires serious cognitive mapping. Spider monkeys rely on extensive spatial memory to track resources, mapping out specific 2-kilometer networks of fruiting trees to secure their daily calories. Others manage the abundance through biological restraint. The northern tamandua consumes up to 9,000 ants a day, but carefully extracts only a small fraction from any single colony. By leaving the nest intact, it guarantees its local food supply will constantly regenerate. In a biome housing thousands of insect species per hectare, the primary challenge is a relentless marathon to outcompete millions of neighbors for space. Earth relies on the diverse mastery of these two environments. The broad-leafed woods of the north survive through resilience against the cold, while the equatorial jungles thrive on raw complexity and aggressive competition. But both ecosystems share a common vulnerability. Temperate deciduous forests once covered vast continuous stretches of North America, Europe, and Asia. Over the centuries, those ancient woods were largely erased to feed the expansion of human industry. The timber and space required for progress forced the clear-cutting of millions of acres, turning massive, contiguous habitats into the isolated fragments we see today. Today, the exact same aggressive extraction is targeting the neotropics. The dense jungles of Central and South America are being rapidly sliced open, replacing millions of years of evolutionary growth with barren tracts of cleared earth. These tropical engines cover less than 6% of the planet's surface, yet they house more than half of the world's plant and animal species. We are systematically disassembling a biological web so complex that countless species are going extinct before they are even identified. Whether built to endure the freezing snow or engineered to harness the endless rain, these systems represent millions of years of specialized evolution. If their balance is broken, that unique biological heritage is erased.